Okay, let's continue on. We've got section 2.3 with our remote videos in your teacher's absence. So today we want to talk about functions. So relations and functions, the domain and range of a function, determining whether something is a function or not, and then something called function notation, and then looking and seeing when I look at a graph of something if it's increasing, decreasing. So let's dive right on in. So a relation is just a set of ordered pairs. So for example, I can define this relation. So it's just a set of ordered pairs, 0, 1, 0, 2, 2, 0, okay, 3, 4, okay. So those are all just ordered pairs. So that just tells me that I've got these things that happen, 0, 1, 0, 2, 2, 0, and 3, 4. So just this set of ordered pairs is a relation, no other condition on that. A function is a relation for which a distinct value of the first component of ordered pairs is exactly one of the second component. So let's just put that in speak here. So let's look at f equal, we'll say 0, 1, 2, 3, 3, 4, and 4, 5. If this is a function, then every time I get the first element, so the 0, the 2, the 3, and the 4, I only get one distinct value back from the second. So I get 0, 1. So I'm not getting 0, 1, and 0, 2. Whenever I plug in a 0, I only get a 1. Okay. So this rule tells me every time you input a 0, you output a 1. You input a 2, you output a 3. You input a 3, you output a 4. Now, if it had also said this, if it said input 3, output 4, input 3, output 5, this is not a function, okay? So what you're really looking for, so if there are no repeated x values, it is a function. Okay, so in this case where I've defined f, there are no repeated x values. Let's look at a function g that looks like this: 0, 1, 1, 0, 2, 1, 3, 1, and 0, 4. So if I look at this relation g, this will not be a function, because if you look at it, I can tell that I've got repeated x values. That 0 is repeated in the x twice. Or another way of thinking about it is when you input 0, you get a 1 and you get a 4. So you're not getting that 1 value. So this tells us that g is not a function. Okay, so let's look at an example they give us. Determine whether this relation is a function or not. So your key to looking at this is just looking at the x values. So for example, I look at right here, my x values are 1, -2, and 3. They are not repeated, okay? So this tells me this is a function. So I know that f, this is a function. The reason I know that, there are no repeated x values. Because to get two different y values back, I would have to have the same x value repeated, and I don't see that. So f is a function in that case. Let's look at the next one, which is g, determining where that is a function. And again, what I'm going to do is just look at the first numbers. So I got 1, 1, 1. I've got that x value repeated. I'm getting back different y values every time. So g is not a function. So again, for it to be a function, every x value gives only one unique y value back. Here I'm getting 3 different y values. The other way of looking at it that people like is just to say, hey, if I see the x value repeated, getting different y values, then it's not a function. And that's what I see here, repeated x values. So g is not a function in that case. Let's look at this one, which is h. So if I look at this, I look at my x values. I've got -4, -2, and -2. I see repeated x values getting different y values. So h is not a function. Another way of looking at relations, we looked at it there with the sets or the ordered pairs, is to look at it in a mapping, okay? So this mapping says, you see the circle on the left, these are all of my x values. On the right, you see these are all of my y values. So what you see here is that the value of 1 gets mapped to 2. The value of -2 gets mapped to 4. The value of 3 gets mapped to 4. So every x value only gets one y value, okay? So this is a function. So f is a function. Now, what would this look like if it weren't a function? Let's just say, for example, 1, -2, 3. What if we had something like this? What if I had, in this case, something like this? What you see here is that the value of 1 is mapped to 2 different y values. So if I wrote this as ordered pairs, I would have to have 1, 2, 1, 4, -2, 2, and 3, 4. That's what this mapping would look like in ordered pairs. And you can see there are repeated x values, okay? Or I've got the same x value going to different y values. So in this case, the scenario you see right here, this scenario is not a function. So let's look at another mapping here, mapping H, and that just illustrates what we were showing here. If you look at it, -4 maps to 1 and -2 maps to 1 and 0, 2 places. This is not a function because you've got -4, 1, you've got -2, 1, and -2, 0 in this relationship. Because I see that repeated x value, this is not a function. So another way to think of function relationships, you may have heard this term before, independent variable, that's your input. The dependent variable is your output. So you're used to thinking of x and y, plug in an x, get a y. Another way of thinking like that is independent variable, input, dependent variable, and output. So what it means for a function is you can't have repeated inputs giving you different outputs. Now there is a term called domain and range that we want to talk about. So the domain is just simply the set of all input, and usually in our case we mean x values, okay, because usually we're doing x and y. The range is just the set of all output, and in our cases we usually mean y values. So we can look at a relation, we can look at a function, and we can tell its domain and its range. So let's look, for example, in this one. So the domain would be the set of all input values, okay? So the domain of this function is going to be 3, 4, and 6. So if you can tell, those are all of the input values, 3, 4, and 6, okay? Now to go to the range, those are all the set of your outputs. So the range would be -1, 2, 5, and 8. So -1, 2, 5, and 8. Okay. Now ask yourself, is this a function? This is not a function because you see those repeated 4s. So I've got 4, 2, and 4, 5. So I know in this case, this is not a function. But the domain and the range can be given if it's a function or not a function. So the domain is the set of all input values. You see that by looking at the first coordinate, 3, 4, and 6. The range is the set of all outputs. That's the second coordinate, -1, 2, 5, and 8. Now let's look at a mapping. How do I find the domain? So the domain is the set of all input values. So my domain, when you look at a mapping, this is your domain, and this is your range. So the domain, what numbers are in the domain? That's just 4, 6, 7, and -3. What values are in the range? That's simply 100, 200, and 300. Now, if you ask yourself, is this a function? It is, because I don't see any repeated x values. And if I were to write down all the points, it's 4, 100, 6, 200, 7, 200, and -3, 300. There are no repeated x values here, so that is a function. And we see its domain and range listed there. Now, let's look at this. Give the domain and range and tell whether or not it's a function. Okay, so in this one, the domain is a set of all input values. So the domain is just the set -5, 0, 5. The range is just a set of all outputs. So that is 2. That's the only output. Is this a function? It is, because there are no repeated x values. Again, if I listed the points, I would get -5, 2, 0, 2, and 5, 2. Now I have repeated y values, but that doesn't have any bearing on whether it's a function. If I look at this, there are no repeated x values. So yes, this is a function. So again, just looking at this, I can look at a ordered pairs and tell if it's a function or not. I can look at it in a mapping. I can look at either of those and tell the domain and the range of the function. So the next thing we want to do is to tell about domains and ranges from looking at a graph. So let's look at this particular one. So this is just a graph of 4 different points. So forget sort of the dotted lines. That's not part of the graph. But really all they did here was to graph 4 points. Okay, and I'm asked to determine the domain and the range. Well, the domain is the set of all x values. So the domain, if I look at all the x coordinates, I've got 0, -1, 1, and 4. Those are all the x values. The range is going to be all the y values. That's 1, -1, 2, and -3. Okay. So that's the domain and the range. Is this a function? Yes, it is a function, because when I look at all the x values here, I don't see any repeated x values. So for every x value, I'm only getting one value. So this is a function.